before the lecture, Ask AI. This question: explain transformer fine-tuning to a fifth grader using a sports analogy. An athlete is already good at running, jumping, and coordination. To become a basketball player, they don't start from zero. They learn basketball-specific skills on top of their general fitness. 1. Why is this faster than someone who's never exercised learning basketball? 2. What general skills does a pre-trained language model already know? 3. If I want the model to answer questions about Kazakhstan history, what basketball-specific skills would I need to teach it? Paste this into ChatGPT, Claude, or Gemini. Understanding this analogy is key to understanding fine-tuning. In the last demo, you used GPT-2 to generate stories. GPT-2 is a general model. It knows a little about everything. But what if you need it for something specific? A general model like GPT-2 or ChatGPT is incredible because it can write about almost anything, knows general facts, and understands grammar. However, it has limitations. It doesn't know your company's specific products. It doesn't speak in your brand's unique style. It often makes mistakes on highly specialized topics, and it can't classify your specific customer complaints. But what if you need a chatbot that knows Kazakh history perfectly, or an AI that classifies customer emails by department, or a writing assistant that matches your company's tone, or a model that understands medical terminology? The solution is fine-tuning, teaching a general model to be an expert at your specific task. Fine-tuning takes a pre-trained model and trains it a little more on your specific data. Let's walk through the 3 steps of the fine-tuning process. Step 1 is to start with a pre-trained model. For instance, GPT-2 was trained on 40 GB of text and already knows the basics of language. Training this from scratch would cost a fortune and take weeks. Step 2 is to add your data. This could be 1,000 customer emails labeled by department, 500 Q&A pairs about Kazakhstan, or 200 examples of your company's writing style. Step 3 is to train a little more. The model adjusts its weights to learn your specific patterns, which takes minutes or hours, not weeks, and can often be done for free on platforms like Google Colab. The result is a specialized model that retains its general knowledge, but is now an expert at your specific task. Let's revisit the athlete analogy to compare training from scratch versus fine-tuning. Training from scratch is like teaching basketball to someone who has never exercised in their life. They have to learn to run, jump, and coordinate before they can even touch the ball. This takes years and costs a fortune. Fine-tuning, on the other hand, is like teaching basketball to a fit athlete who plays other sports. They already know how to run and jump. They just need to learn the specific skills of basketball. This takes weeks or days and is much more efficient. Pre-trained models already understand language. You just teach them your specific task. There are 4 common types of fine-tuning tasks. First is classification. You might input a customer email, and the model outputs the correct department, like sales or support. Or you input a product review and get the sentiments. Second is style transfer. You input normal text and the model outputs text in your company's style or converts a casual message into a formal one. Third is domain expertise. You input a medical question and get an accurate medical answer, or ask about Kazakhstan history and get a detailed response. Fourth is question answering. You input a question about your product, and the output is an answer derived from your documentation. How much data do you actually need? It depends on the task. For simple sentiment analysis, like determining positive or negative tone, you might only need 100 to 500 examples. For multi-class classification, Like sorting emails, you'll need 500 to 2,000. Style transfer usually requires 200 to 1,000 examples. Domain expertise is harder, requiring 1,000 to 10,000 examples. And teaching a new language like Kazakh requires 10,000 or more. The rule is that more data is better, but even a small amount, like 100 examples, can show improvement for simple tasks. You might wonder, why not just use better prompts? Let's compare prompting versus fine-tuning. Prompting is what you do with ChatGPT. It is quick to set up and easy to change, but instructions can be long and expensive. The model might ignore them, and it can't teach truly new knowledge. Fine-tuning, on the other hand, bakes the knowledge in. You don't need long prompts, the behavior is consistent, and it can learn truly new information. The trade-off is that it requires data collection and takes time to train. The rule of thumb, use prompting first if you need more consistency, better quality, or shorter prompts, then fine-tune. Real companies use fine-tuning every day. Bloomberg created Bloomberg GPT by fine-tuning on financial data, making it 50% better at financial tasks. In medicine, MedPalm was fine-tuned on medical textbooks to pass licensing exams. Legal AI uses fine-tuned models to find risky contract clauses humans miss. In customer service, models are fine-tuned to handle 70% of tickets automatically. And you will build a Kazakhstan example, a multilingual model fine-tuned to understand Kazakh business reviews. Here is a simplified look at the technical process. First, you load the pre-trained model, which brings in millions of weights. Second, you prepare your data, creating a list of text and label pairs. Third, you train or fine-tune. For each example, the model makes a prediction, compares it to the correct answer, and adjusts its weight slightly to reduce error. Finally, you save your model. The key is that we are only adjusting weight slightly, so the model keeps everything it already knew. In the next demo, you'll do this yourself. You'll prepare a data set, load a pre-trained model from Hugging Face, fine-tune it on your data, and test the before versus after performance to see the improvement with your own eyes. Let's summarize the key takeaways. Pre-trained models understand language generally. Fine-tuning makes them experts. Fine-tuning is like teaching basketball to an athlete, not starting from zero. You need less data than training from scratch, hundreds, not millions. Use fine-tuning when you need consistency and baked-in knowledge. Real companies use fine-tuning for finance, medicine, law, and customer service. The process is load model, add your data, train a bit, and save the specialized model. Now let's do a quick check to test your understanding. Answer these questions. 1. What's the main advantage of fine-tuning over training from scratch? 2. How many examples might you need for simple sentiment classification? Positive, negative. 3. Name one task where fine-tuning is better than prompting. 4. In the athlete analogy, what does general fitness represent in a language model? 5. What does the model keep when you fine-tune it? Write your answers down. You'll apply this knowledge in the next demo.